I'm Nigella Hilgarth. I'm the Executive Director here at the Birch Aquarium. And it's a great pleasure this evening to welcome you all here and also to introduce our speaker tonight. So it gives me great pleasure to welcome Dr. Ramanathan this evening. He is a distinguished professor of atmospheric and climate sciences here at Scripps Institution of Oceanography, UC San Diego. And in fact, distinguished professor is truly a really good title for Dr. Ramanathan. He is one of our very most distinguished scientists here at Scripps, and we are very, very lucky and privileged to have him here. He is really one of the world's blessed climate scientists. So just to tell you a little bit about him, he received his bachelor's and master's degrees in India, but his PhD here in the USA, and he's made pioneering contributions to our understanding of the global warming problem and the role of air pollution in climate change. And I will let him tell you more about that in his lecture tonight, but I just want to let you know that he is the recipient of numerous honors, including induction to the American Philosophical Society, the US National Academy of Sciences, the Pontifical Academy of Sciences by Pope John Paul II, the Academia Europa, and the Third World Academy of Sciences. He's also received the Buys Ballot Medal, the Volvo Environmental Prize, and the Raspberry Medal. And he currently chairs a prestigious national panel that gives strategic advice to the US climate change program initiated by President Bush. And it's a $2 billion program in climate change research funded by 13 US government agencies. So without further ado, please help me welcome Dr. Ramanathan to his talk entitled Global Warming and Atmospheric Brown Clouds, a Double Threat for Asia.
Nigella, thank you very much for the generous introduction. When you hear, you always feel, I better say something worthwhile to deserve all this introduction. Of course, I want to talk about what's happening as far as climate change is concerned in Asia. I'll get to the reason why I'm focusing on Asia. Just to set the problem in perspective. Most of the problems I'm talking about is pollution, one form of the other, of what we put into the air. Normally, when you look up the sky, it looks vast and huge, so you think it can take in all the junk we are putting in. But when you look at the perspective, the atmosphere is just a thin shell, okay, very thin shell compared to the planetary dimensions. So it's in that thin shell we are dumping, as we will see, billions and billions of tons of various chemical compounds, particulates, acids. So, and what I'm going to try to talk to you today is, how does the atmosphere telling us that it's too much, okay? So we all know, I'm not going to touch too much about all this because we have heard about it tremendously. The world has already witnessed rising sea level, retreating Arctic sea ice, retreating of mountain glaciers and snowpacks. The Sierras are melting early and causing all kinds of water problems. And the Alps is predicted to disappear in about 30 years from now. And I'm going to focus on the Himalayas. And then the projections for the next several decades don't look that good. So the question is, the world does not need another bad news. Unfortunately, it's my misfortune to tell you about one more disaster that's happening. And that's in the form of what I call atmospheric brown clouds. And those of you who were this morning, the first thing I do is when I go out in the morning and look at the sky. Because when the pollution is worse, you'll see it on the horizon as a brown layer. Today was one of the thickest brown layers I have seen in the last year or so. So the brown cloud is not some phenomenon happening out there in India or China. It's happening everywhere. But and my own work is pointing out Asia is particularly vulnerable. So I'm going to talk about how the two, the global warming and the brown clouds, are sort of working together and working against each other. And what does it mean to the water and food security of Asia? And the question is, why am I focusing on Asia? Of course, my background is the dead giveaway why I'm focusing on Asia. But there's also other reason, about 50% of the world's population, 3.6 billion, live in Asia. And the three largest economies of the top 10 are in Asia, between now China, India, and Japan. And we'll also show that there are other reasons we should worry about what's happening in Asia. I'll come to that. So what's the source of pollution? Of course, first is industry. When you see that is smoke, particulates, okay, coming out. Coming along with this smoke is what we call gases, greenhouse gas. It's invisible, it comes out of your tailpipe. So there are two things happening at the same time, okay? And then, of course, automobile transportation. And the third is biomass burning, deforestation, agriculture. That's my village, where I come from in India. And indoor cooking. And that's my grandfather's home, village home. And you would think I took this picture when I was young, which is 55 years ago. No, I took this picture 2 years ago. So it's happening. So the question is, why should my grandmother, she's not alive anymore, let's assume she's there, why should she worry about what car I'm driving? Likewise, why should we worry about what my grandmother is cooking, what she's cooking with? Take a close look at the next movie. It shows how the air travels around. So this is a climate model I helped develop at a center in Boulder before I came to Scripps. And the clock is ticking here. And you'll see in a matter of 3 to 4 days, air comes all the way from East Asia across into the US. So while the Chinese are sending their gift to us, we in turn are sending our gift to our European friends. And they return the favor back to Asia. And look at what's happening in the Amazon region, all the forests, how quickly air travels across into the Antarctic, okay? So contrast that with the fact that what we call gases, carbon dioxide, is a major greenhouse gas. And just to give you a little bit of background, what is carbon dioxide? Every fuel you talk about, the wood, the fossil fuel, or paper, ultimately when you burn, the fuel is carbon and hydrogen. We call them hydrocarbons. The carbon becomes carbon dioxide, combines with oxygen, and the hydrogen becomes water vapor, okay? So everything we do ends up as carbon dioxide. This carbon dioxide lifetime, of course, Scripps, Dave Keeling pioneered the study of this. Scripps is world famous for that work in carbon dioxide, so I'm not going to touch on that. But its lifetime in terms of decades to centuries. So when we scientists say, what do we mean when we say decade of century? If you capture the carbon dioxide coming out of your tailpipe, let's say in a can, and put a flag to it, and release it, you come back about 100 years from now, about 30 to 35% of that can would still be out there, that molecule circling around. So it's something long-lasting, okay? But on the particulates, on the other hand, stay there only for a few weeks, thank goodness. So there are two different problems. So think of the carbon dioxide now. I'm going to place first, before I get into the brown cloud issue, I'm going to put the greenhouse warming in context and then talk about the brown clouds. So what we have done is surrounded the planet with a blanket of these gases. Okay? Carbon dioxide is one of them. So why should we worry about this blanket? This semester I'm teaching a course on climate. So I'm going to condense my 3-month course into 10 seconds, but give you a background on how the climate is driven. The fundamental energy source is sunlight. Not all of the sunlight is absorbed by the planet. It reflects about 30% back to space. And I spent my early years figuring out this using satellite measurements. So about 70% of the sunlight reaches the ground, we know that, and heats the surface. So the whole ground and the air warms. And what it does is, ultimately everything has to be balanced in nature, Okay, it's an energy balance, what we call energy balance. So the incoming sunlight isn't given off as heat radiation. We call it infrared. It's the same thing how the infrared camera works. So this process of sunlight coming in, heating the planet goes on until what comes in goes out. So the system is in energy balance. And this was in this happy energy balance until about a few hundred years ago when Mr. James Watt invented the steam engine and then started the problem. And so now this blanket is surrounding. What does this blanket do? What does a blanket do on a cold winter night? Why do we put blanket? It keeps us warm. Not because the blanket gives off heat, it just traps your body heat. That's exactly how the carbon dioxide does. It traps the heat which would have otherwise escaped the planet. Okay? So it's not a big complex thing. It's a simple phenomenon. But the energy trap, we know how to estimate. That depends on the quantum mechanics. Okay, I'm not going to get into that, but it goes to fundamental laws of physics, and we know how to calculate how much heat is trapped. I'll talk to you about that. So basically, think about this blanket, and the blanket is thicker. Normally, I use this metaphor, but on a night talk, I worry you. I talk about a blanket, and it keeps you warm. I'm afraid you're going to go to sleep, but I'll quickly change the topic. So think about this blanket nature has given us. Okay? It's not that there is CO2, carbon dioxide in the atmosphere, background, in nature, and we are adding to it. There is also water vapor, which is a powerful greenhouse gas. So the blanket is massively thick, and we have made the blanket thicker by about 2.5%. This was my early work, 10 years, calculating that precise percentage. And so the planet has to heat up and warm. Okay, so that's the simple thing. Until about 1970s, we used to think the main culprit is carbon dioxide. Okay? And so this is a famous report published by a group at MIT. And of course I was so impressed with this group, they had this prayer from a Sanskrit prayer. It's a famous prayer about worshipping Earth. And in this study, they concluded that carbon dioxide is the main way humans are impacting. And this is what when 1970s, when I came from India to the US, and I finished my PhD not studying Earth's atmosphere, I was more working on Venus and Mars. And I graduated in 73. I could never find a job when I told everyone I'm working on Mars and Venus, even in the US. But I wanted to go back to India. My father told me, I remember so clearly, he's not alive anymore. He said, you better stay in the US. What you're working on seems so worthless to me. Only US is rich enough to pay for this. Unfortunately, even US was not rich enough to give me a job, so I had to switch my job. I joined an obscure group at the NASA Langley Research Center. They were working on re-entry physics. Anyway, not being an earth scientist, I had not read this report. So it was at that time, 74, Maria Molina and Rowland, who both got the Nobel Prize for chemistry, they said this chlorofluorocarbons, which you're releasing as refrigerants, as propellants, was destroying the ozone layer. For varieties of reasons, I got very interested in this, and I was also finding I wanted to do something useful. And so it turned out, I accidentally stumbled on the fact, because I had done classes on quantum mechanics, that the chlorofluorocarbons are also the most powerful greenhouse gas. Okay? So much so, my work pointed out, one molecule of CFC has the same greenhouse effect as adding more than 10,000 molecules of carbon dioxide. Okay? So here it is, as human beings, we have invented, because CFCs, it was synthesized, it's not a naturally occurring compound, a molecule which is a super greenhouse gas. So much so that it's an English physicist who writes novel. He said that's a way we can, make Mars habitable. Send CFCs, it'll give enough greenhouse effect to heat Mars, which will unfreeze all the water, etc. Okay. But what this work did is said that the system is more complex than just CO2. And this, of course, I wanted to mention to you, this has become set a trend where I've been attacked viciously at times, scientists could be vicious, is when this work came out, unfortunately, it got to the probably one of the earliest papers, which was on the front page of New York Times. And that angered some distinguished colleagues. They simply dismissed this work as, I think one famous Harvard professor I heard described it in 2 words. He said it's BS. And the Princeton physicist said it's a dangerous idea. So it took the community about 10 years to prove that this was correct. Okay? Various people had to repeat what I did. So what it did was that what we thought was 3 separate problems: the greenhouse gas, the ozone depletion. CFCs are involved in ozone depletion. Then I'm going to talk to you about the haze. They are all interconnected problems. They are all impacting climate. They are all impacting human health. They are all impacting water budget and food security. And I'm going to tie that for you. Okay? So in any case, in '83, we proposed that the non-CO2 trace gases, after we talked about CFCs, there was a Pandora's box was opened. There was numerous, over 20 compounds we are putting into the air. They're all making the planet warmer. Okay? So this was, finally accepted by the international community in the year, 2007. This is famous IPCC report. It was this group which was given the Nobel Prize, and I was, of course, involved in this work. Several Scripps scientists were involved in this. They finally show that, this shows how we are heating. Think of this as the blanket, okay? That is how much the CO2 is thickening the blanket, and then this other numerous other gases. So they were about 45, then there is another green, so when you add this on this is the ozone, it's also greenhouse gas. So the other gases are amplifying the warming as much as CO2. So suddenly the problem has become a lot more urgent than what we thought. If it was just CO2, the warming we would have seen was about a half to third of what we would have seen, okay? So I just want to mention to you, from the rest of it, I'm going to talk to you about how we used observations in my group. We had to design many of them to track this problem down. So of course, for me, my work is depressing. It's just talking about the various ways we are messing up the planet. But the fun part is figuring out how it's done. So I use satellite instruments. I had designed a couple of instruments on a satellite early on. Then we set up surface observatories, and we do field campaigns and modeling. And my last one I'm going to show you using unmanned aircraft. These are miniaturized instruments. In other words, we are trying to start the age of robotics measurements of the atmosphere. Okay? So now I want to give you a little bit quantitative information. Remember, I said the blanket we have increased by 2.5%. In terms of heat, that's about 3 watts. Watts is the same as light bulb. We say 60-watt light bulb energy per square meter of the Earth's surface. For every square meter of the Earth's surface, we are trapping about 3 watts. But that makes sense to scientists, but how do we calculate that? So how many, that's equivalent to burning a 60-watt bulb for every 20 square meter. That's a typical bedroom of an undergraduate student at UCSD, okay? So how many such bedrooms are there? 25 trillion. In other words, the heat trapped by this blanket surrounding this huge planet is equivalent to burning 25 trillion 60-watt light bulbs day and night throughout the year. And we have done it over the last 30, 40 years, if not more. So we shouldn't be surprised that the planet is heating up. The real surprise is why it has not heated up a lot more than it has. And then I want to come to that. There's one other thing I want to mention is if you go back and think, why does summertime warmer, it gets humid? When it's got cold, it gets dry, right? When you go to tropics, it's hot and humid. You go to the poles, it's cold and dry. Simply because the amount of moisture you can hold in the air depends on temperature, okay? So when you drop the temperature, the air condenses, falls as rain. Same reason, you put a pan of water and increase the temperature, what happens? The water disappears. Where is it? It's as vapor. But remember, I told you vapor is the most powerful greenhouse gas on the planet. So when you heat the Earth, you're heating the ocean. The source of water is ocean. The ocean evaporates more vapor, and that vapor spreads around the planet. Okay? And we call what's called thermodynamics. It tells us precisely how much. So there's no leeway here. So it's about 6 to 7% for each degree rise in the temperature. And that then, so think of it now, this blanket around your body. You made the blanket thicker. You are warm, it makes you sweat, so the blanket is getting wetter. The wet blanket traps more heat, and that planet has to work even harder to get rid of that. Okay? How much hard? And we know that. And now that's what my work was, using satellite measurements, doing this trapping, and then people have modeled it. It's about twice as hard it has to work to get, twice as warm it has to get rid of the same heat. Okay? So now the question is, when did we know all this? I think most of you have heard of this global warming, I'm sure, from Al Gore. And many has come and talked to me. It's amazing how a single person, even though he's a politician, he has discovered so much about climate change. So I want to mention this has been going on. In fact, the first work on carbon global warming was done by a famous Swedish chemist, a Nobel laureate, Svante Arrhenius. He modeled this in 1898. First paper was a quantitative paper. And we have known about this 200 years at least. And I'm just showing to you in 1980, teaming up with a well-known meteorologist, we looked at when are we going to see the warming. This is by the time I had talked about the other greenhouse gases, I know the problem is a lot more serious. So we published this paper 28 years ago saying that if our theories are correct, and if our observations are not misleading us, we should detect this warming year 2000. It's probably one of the earliest, if not the first prediction made, quantitative, using mathematical models and statistical analysis. This is what you can call the major, fingerprinting of the warming. Why many have converged that it's happening. This is the temperature collected over the planet, okay, over the oceans. In the ocean, it's a water temperature. This was, when, in fact, most of the work was done when North America was discovered. Was Columbus come, so they started measuring water temperatures, right? And then land temperature, we measure the air temperature. Balloons are launched. Over 2,000 balloons are launched every day around the world. So that shows the planet has been gradually, there are a lot of hiccups up and down. These are natural variability, okay? And then it's warming and warming and warming. And this shows the trend. You can see the trend is accelerating. Okay? So we predicted the warming would be detected by 2000. Of course, the 2001 report, IPCC, said, yes, we are seeing the warming. It's due to human activities, okay? But the interesting thing which has gotten unnoticed, and this is a problem I and a few others are working on it, the total warming here is about 0.8 of a degree Celsius, or in terms of Fahrenheit, is about 1.5 degrees it has warmed. But the predicted warming is about a factor of 2 to 3 more. Okay, this is not being advertised. So what happened? Is this probably our models are wrong, or is something going on we don't know? And that something going on is when you bring in the brown clouds, okay? So the warming is confirmed, but the magnitude, if our models and theories were right, it should have been somewhere there. The planet should have heated a lot more. So that's the point I want to address next. Yeah, so I'm coming to now, something has made the warming go away, okay? By sheer dumb luck, and I want to talk about that dumb luck. And I call it masking. And of course, I visited in a meeting in Venice 3 years ago. The first time I discovered the Venetian masks, and I thought, what a nice prop for my talk. So I'm going to show you some, figures, but let me just, I don't want to keep you in suspense. So just to bring the whole thing in a nutshell, As we are dumping these gases, you saw that smoke coming out, okay? So some of those particles were reflecting sunlight. So basically, going back to the blanket, we have been putting mirrors on the top of the blanket. While we are trapping the body heat, we are also sending the sunlight back, okay? And this was what was proposed by at least 30, 40 years ago from scientists called, well-known people, Mitchell and others, you may not know them. But that was not my work. They basically said the sulfur pollution, coal combustion put sulfur dioxide, which becomes sulfate particles. And we used to think of the sulfates as acid rain, but it turns out they're also having a major climate issue. But what's new, this was the work done at Scripps, is that we used to think of this haze, when you see the brown clouds, you think of it as an urban problem, okay, or local problem. By doing field campaigns, what we have discovered is that these could quickly travel and become transoceanic, transcontinental plumes. And I'm going to show you a number of examples of those kind of plumes. Just to bring you to home, this is, of course, the picture I took during Christmas time, 2002, the brown cloud in Los Angeles. And when I talk about this in California, at least the government official says, oh, it's unfair, you can't compare our brown cloud with Indian brown cloud, it stays there forever. This comes only when we have inversion, which is true. So I asked them, what do you think when the brown clouds are not there, you think we are emitting less? No, we are still driving the same cars, we are dumping the same amount. When it is not trapped in California, it's traveling downstream. We are just giving this gift to the rest of the US. So we have a false notion, oh, this brown cloud is a 2-3 day problem. It is nice if it gets stuck in California, then it gets washed out. When it spreads, then it has a huge impact on the whole continent. So this is, you can think of just one day snapshot, river of pollution coming from India, the Indo-Gangetic plains. So here's a satellite picture when we're doing the experiment, 2001, it's 2006. So it's not happening one day, it's happening all the time. And the problem is the tropics has a long dry season, like a permanent inversion for 6 months. So the pollution has nowhere to go and it gets trapped, okay? And so we mounted a major campaign. This was a Scripps initiative. Over 200 scientists from around the world were involved. And we took a ship from here, and the Indians brought a ship. It was a major collaboration. Over 100 scientists from India worked. And we took C-130 from the US. The Dutch brought the Citation. The Mystère was brought by the French. The Germans brought the Falcons. One of the truly international experiment. But Scripps was the host. Cost over $30 million. And the Europeans even moved a satellite to observe the geostationary. And so there we discovered this brown cloud phenomenon that could be large. It's impacting climate in a huge scale. So I'm going to show you a quick journey. So what we did was that, you see, pollution is coming from Asia into the Indian Ocean. And here south in the Indian Ocean, seeing the pure, cleaner air from Antarctic. So we used to go north and south. Let me show you a dramatic picture I'd taken when I was the mission scientist. So this, here I'm about a few hundred kilometers from Bombay, all right? Can't see anything in the cloud. I'm in the Arabian Sea. Here, I'm about 1,500 kilometers away from any source in India. I'm in the middle of the equatorial region, Indian Ocean. You can see the clouds. And these are the particles we captured with scanning electron microscopy. So then I'm going on close to equator. I had to go to 8 degrees south, close to Diego Garcia, to see blue skies. So that's how vast it had spread. So why should we, that's the particles nature produces. We call them sea salt. And then planktons in the ocean emit particles, okay? They're kind of round shape, and this is the soot, black carbon. I want to talk to you about that. And so we also, measured the chemical composition. No one could doubt or debate our findings because I knew air pollution is always a controversial phenomenon. Those of you who know, about 30 years ago, Canadians used to blame us for their acid rain. We used to blame them for our acid rain. So air pollution is always a transboundary problem, pretty controversial. So we had to do everything, hit everything we could so that no one could doubt. So doing this, we knew 80% of the particulates in the ocean was coming from India and South Asia. And the major thing was the black carbon. I'm going to talk about the soot and sulfates. So where are these plumes? This is the paper we are just publishing in 2008. Different months, December to March. Okay, that's the Indo-Asian Pacific plume. When it's yellow, that's our scientific units, you will see thick brown haze. So that's what yellow means, okay? And then you can see the North American plume, our pollution peaks in July, all the Ohio Valley, all the coal combustion, you can see how that's traveling across the Atlantic. These are all yearly, 5-year average. So these are quasi-permanent phenomenon. Then the South Asian, Australian plume, the savanna burning, and the Indonesians burning everything they have. And then the savanna burning in Africa, and then various things. So I, in fact, had to do this in any case, because by the time we published our ABC India findings, I was almost became a persona non grata in India. So they, in fact, in a famous meeting, they accused me as that I'm being funded, me and my colleagues, funded by the oil industry to divert attention away from the greenhouse issue into this air pollution so that you could blame India and China for this. And so on and so forth. That's not surprising to me. When I was in the University of Chicago, I published my paper about the greenhouse gases, how they're, and a Chicago radio person, I remember very well, introduced me, and he said, we're going to talk to a spice-eating Indian scientist with an unpronounceable name. He has come to dismantle the American industry. So both my adopted country and my mother country have blamed me for destroying industry. So you see, this is the black carbon emissions, what's coming from the ground, and you can see where it's all coming from. This is what we found. What is it doing? It's called global dimming. Okay? This particulates, by reflecting sunlight and absorbing it in the atmosphere, that is the soot, cutting down sunlight going into the ground. And some of this is very large, it's about 10%. In other words, we have the power to reduce the sunlight by 10%. Okay? And you can see everywhere. And the dumbest thing we can do to the planet is cut down sunlight. We need sunlight for photosynthesis, for life, but you need sunlight for evaporating moisture. How do you think we get rain? The sunlight reaches the ocean, the water molecule absorbs that energy, and then it is sprung loose, becomes vapor, and the wind advex, and we get rain. So when you get sunlight, the first thing which will happen to you is you'll reduce rainfall. But the effect is most pronounced in the Asian region. And there's another disaster waiting to happen in Africa. No one is even studying that yet. So do we see evidence for this? This is the rainfall trend for the last 50 years. And you see, this is the region I'm focusing on. This is so-called Indo-Gangetic plains. You can see the rainfall has decreased by 15–20%. What's happening in China? What is the big problem with the Beijing Olympics? The whole northern China is getting dry. What happens? Things get dry. It becomes dustier, more polluted. Why is the particulate lifetime 10 days? Rain removes it, and we know that. After rainfall, the sky looks blue because the rain removes the junk. So you cut down rainfall, you're going to increase your pollution. So there's a major shift. When we published this work about 4 years ago, the Indian meteorologists were up in arms. They said, oh, this is natural variability, it's not really happening, it's not trend. Fortunately, the IPCC group said, yes, South Asia is drying. And just this year, 2 months ago, 2 Indian scientists, meteorologists, published a paper saying the whole monsoon is shrinking. The problem with that is there are over 600 million people living in this area. This is the so-called breadbasket of India. That's where all the agriculture, okay? And of course, we all know about the Sahelian drought, which wiped out over millions. In fact, the Sudan crisis is based on this drought, people trying to move south. So it's political. I don't want to simplify everything into climate change, but this is what is happening. So the rainfall is decreasing. And this, an Australian worker has pointed out, this drought, they are saying, is because of the pollution coming from North America and Europe cooled off the North Atlantic, this brown cloud. So when you cool the ocean, you're going to reduce rainfall. So do we have evidence for this? This is something we took. This is our simulated values of sunlight over India. And these are actual station observations. And we were able to simulate this decrease. In other words, India is becoming darker, has become darker by about 7%. And our work suggests it's all coming from pollution. What is the big deal about 1950? That is when the population of the world became from 2 to 6.5 billion. Major increase happened after the World War, 1950s, and major industrialization. Okay? So the last thing to conclude, then I want to go on. This is the impact of the reduced rainfall on wet season harvest. We teamed up with 2 economists. India's agriculture was going rapidly, and then after 1990, it leveled off. And they're scratching their head why they're dumping, all kinds of fertilizer. It's not helping. Our work is suggesting it's because of the brown cloud impact on monsoon rainfall. And yeah, I'm going to skip this. So let's go to the. I want to talk to you about one more disaster story, and then I move on to solutions. That's what I'm working on. Okay. If that was the only thing happening, it wouldn't be a problem. Unfortunately, the glaciers in Himalayas are retreating, okay? And unlike the glaciers in the rest of the world, the Himalayan glaciers are the source of major rivers, the Ganges, the Indus in Pakistan, Brahmaputra that comes from the Tibetan part of China, but goes into Bangladesh, Nepal, India, Mekong is Vietnam, Yangtze, and they're all depending on the glacial retreat, melt. The problem with the glacial retreat, about 2/3 of them are retreating. This has been documented by Chinese. And the problem with the glacial retreat is that when the glacier is melting, you think you've got abundant water. So you say, what is the problem? When more than half of it is gone, then things start becoming dry. Okay? So they have not passed that halfway stage yet. What is the connection between that and the brown cloud? There are hundreds of such horror stories you can see about the glacier. I'm particularly showing a lot of work by Indian scientists because it's coming from locally from their source. How do we detect the brown clouds to the Himalayan glaciers? We took our UAVs. It was the first thing that was done. We flew 3 UAVs over the Arabian Sea, captured the brown clouds in between our aircraft, and measured exactly how much sunlight is being absorbed by the soot. Okay? And then the satellite showed this brown cloud, the whole Himalayan Tibetan region is surrounded by these brown clouds. So that's like a shoebox size. This whole aircraft is about 8 feet wingtip to wingtip, and we miniaturized these instruments. And so that was what was flown, all kinds of things. So just to capture what's happening, so that's the glacier area, starting from the Hindu Kush Mountains, Himalayas, and then the Tibetan glaciers. And you can see all the rivers flowing out of that. And this thing is surrounded by these brown clouds, and there is soot there. That's what you see. The soot is basically what you see coming out of diesel combustion, or when you burn things, when you have fires, you see the black smoke coming in. It's black because it absorbs sunlight, okay? So it's heating the air, and the warm air moves up the slopes and contribute to the melting. So we found that half the reason it's melting is, of course, the carbon dioxide, but the other half is coming from the brown clouds. Okay. The key thing, what worries me the most, is the coupling between energy and water. Okay. Right now, our energy use is sort of independent of our water use. Okay? But of course, the energy use causes climate change, which depletes water. But then we starting to use energy for water. I'll tell you the other biofuels, I'm going to touch on that, okay? And if things dry up in California, it's going to happen. We're going to use energy to move water from where it's plenty to where it's not. And then we've got another whole disaster coming downstream, because then you're pumping more CO2, and then more CO2 is drying more, and you're, so these kind of nonlinear feedbacks, what we call in the scientific community, is what we have to be careful. Just to finish the story. Remember I said that about 2/3 of the warming is missing? So this is the warming we have committed the planet to. I'll tell you what I mean by committed. We have committed the planet to a 2.5 degree warming, or 5 degrees Fahrenheit, no matter what we do now. This is based on the accumulated greenhouse gases over the last 100 years. We are not seeing that. We are seeing only 1/8 of a degree, because on this blanket we have these mirrors reflecting the light. Okay? If that was the only thing we were doing, life would have been simpler. Unfortunately, while we put mirrors on the blanket, inside the blanket we have put this dirty soot, which is also trapping sunlight. Okay? So there are multiple things happening to this blanket. So when you leave the room, be careful how you take off that blanket. Okay? I'll tell you how to take off that blanket. But in this blanket is this black carbon, which is contributing to heating of the planet. Okay? I think there lies in one answer to how to solve this problem. Okay? So keep track of this. So the reason the planet has not heated up is because we have masked it. The problem with that is air pollution hurts human health ecosystem. So if our air pollution laws are successful, I hope they're successful, this masking would go away and the planet would rapidly heat up. So this is what in my community we talk about. They made a Faustian bargain. Okay? So we put this greenhouse gases, we also put this particulates. So we are thinking, oh, the greenhouse gas has not done that much but 0.8 degree warming. Now, when we clean the planet of air pollution, it's going to witness a rapid rise in the warming. Okay? So, and that raises the question, how do we avoid crossing so-called climate tipping points? Because many believe when you heat the planet beyond 2 degrees, things like the Greenland ice sheet could start melting rapidly. And most scientists are thinking that we have not crossed it, but I'm pointing out here, we have already crossed that threshold. We have just not seen it. Okay? So I think I need to wrap up. This is the issue of consumption versus population. If you look at the total world emission of greenhouse gases as of 1995, of course, the western region was the major contributor. Okay? But 20, 30 years down the road, our role will be shrinking, thank goodness, but the others are filling in from Asia. But the greenhouse effect is accumulation. So it's based on last 50 years, not what we emitted today. So if you look at that in that fashion, then of course a lot of the emission so far has come from the West. But if you look at the next 30 years, things are going to change rapidly. Unfortunately, our energy demand is going to grow by 55% from 2005 to 2030 because the population is going to go to 8 billion, 6.8 billion now, and also China and India are getting richer. Thank goodness, where their economy is improving, but at the same time it comes with a price. So they're going to contribute at least half of this world's growth. This whole engine is going to be driven by China and India. So that's the reason we need to focus on Asia, understand what's happening there. And of course, China is now already or the largest consumer of energy is CO2 emission. We have to worry for other reasons. Like I said, the pollution travels rapidly across. We did an experiment following this plume, okay? And normally when it calls Pacific Ocean, we have found it happens in these walls. There's a wall of pollution coming. In fact, this is dust we measure. When I look at it, I comment to my colleagues, if Genghis Khan was here, he wanted to attack America, he would come behind these plumes with his guns, we wouldn't see him. But we are watching Genghis Khan. we have started, as of this month, I am very happy to say, routine monitoring of the California atmosphere, air pollution, looking for local and long-range transport of pollution to understand what's coming outside. So we have started this in the Antelope Valley, this in the NASA Dryden base. It just happened last week. So we're going to, I think we have proved the concept, so we're going to start doing this every month. We hopefully by this year end, we'll have a little bit better idea where our pollution is coming from. How much is local, how much is coming from Mexico, how much is coming from north of California, and how much is coming from East Asia. That's our hope. The second thing is, we're also doing this campaign off of Beijing, Korea. The Chinese too they don't know this, we're doing it. See, they've cut down their pollution because of the Beijing Olympics. For people like me, that's a fantastic natural experiment. So we are starting our observations starting this June from Korea, teaming up with Korean airlines, a lot of Korean scientists, and scientists in China. So I want to conclude my talk with what's in store for us. See, we are putting out every year 7.5 gigatons of carbon dioxide, 7.5 billion tons. Just imagine how much a ton is. And you shouldn't be surprised. We fill our gas tank every week, right? Or 10 gallons. Where is it going? All going into the air. So it's all weight. All the fuel is in the air, okay? And if we continue on our using mainly fossil fuels, that's the curve we are going to go. And they made projections assuming that for another 30 years, no one is going to pay attention, and then they start decreasing. It's too late because the planet would heat up by 5 degrees, okay? Very few of us would be there in that planet. It's our grandchildren, great-grandchildren. I want to tell you how rapid it is. Even if we realize, say, 2015, oh my God, there's a serious problem, let's start cutting down, we are still going to see 3-degree warming. And we are not seeing it because of the aerosols, the brown clouds. Let's say 30 years from now, everyone would have clean technology. We're going to see 3 degrees. And that's what most claim is the climate tipping point. So, and how are we solving? There are many things. Unfortunately, biofuels, we are rapidly running into it. All 3 presidential candidates support it. It looks like it's another disaster in the making. Because biofuels, first of all, you require energy to convert solid to liquid fuel, which is a warming effect. And so Professor Crutzen has just published a paper saying that, to convert farmland, you need more fertilizers to grow corn or sugarcane. That releases nitrous oxide, the most deadly greenhouse gas. So it's a warming effect. This is the problem I'm working on. If you take fallow land, which is dry, it reflects a lot of sunlight. You cover it with green plants, even if it's crops, it decreases albedo, another warming effect. And the fourth, we are going to be using tremendous water for irrigation. Everything is going to create energy. And we don't know where it all ends up. The problem I must tell you is, I would thought in this modern day and age, before we start a new technology, we will consult with environmental scientists, at Scripps, what have you, and first understand what impact is it going to have before we unleash the technology. We are not doing that. I have my own solution for this, a small solution. I want to conclude with this. Remember I said this blanket had mirrors and then it had this dirty soot in. It was heating. It was retreating the glaciers. It's responsible for the Arctic sea ice. Black carbon is something we know how to reduce. Our black carbon emission in the US has come down by a factor of 2. Europeans have cut it by a factor of 3 to 4. So the technology is there how to do it. It's what's classically called low-hanging fruit. And India particularly, remember I said my grandmother? So we'll pick on her, and if we can convince her to switch cooking from wood and cow dung, because it's a major source of black carbon. So I know she would be hard to convince. She's pretty opinionated. So I teamed up with the scientists and did the simulation, just cut down emission from home cooking. And you can see India like this could become like this, blue skies. 60% of the problem would be gone. And that's equal to saving the planet about 5 years' time. Okay? So we have proposed this. I've teamed up with some epidemiologists because the indoor cooking is responsible for 500,000 deaths. The other interesting thing is it's poverty alleviation. You see, these women, these are the two regions we have picked, one in the Himalayas because we are thinking most of the black carbon is settling on the snow and the Indo-Gangetic plains. And these women here, they spend about 3 hours collecting wood. I mean, all the close by wood is all gone. So they walk 2-3 hours. And the daughters are walking 2-3 hours to picking water. I don't know what the men are doing. They're sitting and enjoying. I go to the Indian village, I say, why did I come to the US? I have to do my own dish cleaning in this. My wife and kids would have done everything for me if I stayed in an Indian village. But it's causing, all the deaths. So it sort of couples into poverty alleviation, climate change. I want to conclude with that. What are we doing? We are promoting cooking with solar cookers and biogas plants. Take the same cow dung and food waste, put into this, convert into methane and burn methane efficiently. Okay. And so we are sort of, we don't have funding yet, but we have been proposing this, writing papers, and hopefully we'll go into implementation stage. Now, Jill, I just want to conclude this because remember, my career was studying Venus and Mars. And I spent 5 years and 35 years squeezing in Earth in between. But there is a lesson here. There are several skeptics who tell me, the planet has existed for millions of years. It knows how to get rid of the CO2. It's resilient and all this. What I think of is, really scientifically indefensible statements. Just want to give you one reason. Look at Venus. Venus is closer to sun. So if you look at the sunlight Venus gets, it's twice as much. Okay? And Venus is hot. As you know, it's super hot. And you can, the classic thing the planetary astronomers say, you can just fry an egg on its surface without any energy. But the question is, you need to get there first and cook your egg. The temperature is about 425 degrees Celsius. Okay, no, life as we know can't exist. So you immediately say, see, it's sunlight, because most of the people are blaming this warming on sunlight, or sun is very. So you can quickly say, what's a big issue? It's receiving more sunlight. No, because Venus is covered completely with clouds. Why is this the brightest object? It's completely cloud covered. So it reflects 70%. So the actual sunlight absorbed by Venus, this is some of the things we had done earlier in my graduate work, is even less than Earth. How did this get into such a bizarre way? Because its carbon dioxide concentration is 1,000,000 times more than Earth. What's keeping Venus hot is the greenhouse effect of carbon dioxide. Why does it have more carbon dioxide? Marine geochemists at Scripps can answer that question. Oceans take up the CO2, they became too hot, there are no oceans there, there's nothing there, everything is in the air. So we know things can go out of control with greenhouse effect. Thank you.